Making games in Unreal Engine is hard, but in this tutorial I guide you through all the levels you need to know to start building your own game. So you've installed Unreal Engine, and that's where level 1 begins. The layout. Unreal is made out of 4 main panels. The viewport, which is your window into the world. You can fly around by holding your right mouse button and using WASD. Then you have your outliner, which lists all the things that are placed in the world. The details panel shows all properties of the object that you've selected. If I select one of these cubes here, I get all these properties to tweak to my likings. And lastly, you have the content drawer, which you can fold open by Ctrl Space or just by clicking on this content drawer button. This is where all your assets live. You create them here and you can just drag them into your level like this. And that's your basic toolkit. And once you know what these pedals are, it's time to move on to level 2. In this level, you learn about blueprint fundamentals. This topic is very broad, so I'll keep it straight to the point. But I have a bunch of other videos that go more in depth on these fundamentals. I'll put those on screen when I talk about them, and you can also find them in the info cards top right. So Unreal Engine works with actors, and your game will contain a lot of them. An actor can really be anything in your game that has functionality. This could be a coin that you pick up, a radio that plays music, or anything else you can really imagine. You can create an actor in the content drawer by right-clicking, Blueprint class, and then you just select an actor. Make sure you give it a proper name, double click on it, and now it opens. And now you're in the blueprints view where you can build your actor to anything you'd like. Open the event graph by pressing this button and you will see there's already 3 red cards by default. These cards are called nodes, by the way, and the red ones are events. Events are like triggers, as if you're firing a gun. So begin play happens every time you start playing. Event actor begin overlap happens when something overlaps with the blueprint, and event tick happens every frame, but you gotta watch out because it will just tank performance. For now, I'll just hook up a print string node on begin play. Give it some nice text like hello world, I am alive. Compile and save in the top left. Back in the content drawer, make sure you drag your actor into the level, and now when I start playing, I get a hello world, I am alive text in the corner of my screen. Great. So we've placed the actor, but we cannot see it yet. That's because it doesn't have a mesh assigned. Right now it's invisible and it has no collision. It is there technically in the world, but you just cannot see it. So what I'm gonna do is I'm going back to the blueprint editor. So I'm just going to drag this panel so it's on the same screen. It's quite nice. Now I'll go to the components tab here on the top left. And here you can add as many components as you want. This can be audio, it can be VFX, a static mesh, and you can even create your own custom blueprint components that you can reuse on any actor. So for now, I'm just gonna create a static mesh component. So let's make this just a cube. You can also just use static mesh. Then in here, static mesh, you assign a mesh. In our case, it's gonna be a cube. And we can see it if I go into the viewport. You can see the cube is right here. This is your visual of the blueprint. This shows how your blueprint will look. And if I now go back to my level, you'll see this is where my cube is, or BP actor. This is the actor that I created just earlier. So yeah, when I play it, you see the cube. Great, but it's not doing anything yet. It's not very interesting for a game. So let's make it do something. Let's make this cube move from point A to point B in the world. So to do that, we're going to use 2 nodes. A timeline, which lets us create smooth animations over time, and a lerp, which is short for linear interpolation, and this lets us smoothly transition between 2 points. But first we need to define those 2 points, our start and end positions. We do that using variables. A variable is like a container that stores data, like XYZ coordinate in the world with a vector variable. So we will need 2 variables, one for the beginning location and one for the end location. You can do that here by pressing this little plus button next to the variables panel. Let's call this begin position. And on the type, we'll just make this a vector. These are like the most common variable types. The yellow one is a vector. As mentioned, it's XYZ position. So if you compile, you'll see XYZ position. And we're going to create a second one for end position. So yeah, as mentioned, step 1 is to set their values. So for now, I'm just going to get rid of these. We're not going to use them for now. And on begin play, we need to set these values actually. So let's start with the begin position. So you can just drag your begin position here. You get 2 options, get or set. And in this case, we want to set the begin position from the start. So what I want to do is not set this to 0, 0, 0, but actually get the actor's location in the world. And you can easily do that by right-clicking and say get actor location. So what this does is it gets the actor location, so the current location of this thing in the world, so this location, and it will output this vector value, which we can just easily drag into the begin position. And there we go. On begin play, we set our begin position to the current location of the actor. Great. Oh yeah, by the way, you notice the target says self, and it just means it's grabbing the location of this actor, our cube. So for the end position, we're gonna move the cube a little on the X position. To do that, we will again use the get actor location. So just get actor location. If I can type, there we go. But this time we want to modify the X value to give it a different location. So what you can actually do here is on this yellow pin, you can say split struct pin, and it will split it up into 3 float values, the X, the Y, and the Z, instead of like a combined vector. This is nice because we can now just individually tweak the X and, well, keep the Y and the Z the same. So I want to modify the X value, so I'll just get this float value and say add, and I want to, for now, let's just say it's 200. And from here, we want to make it a vector again. So just make vector, and we just want to keep the Y and the Z the same. So what we're doing here is we get the location, we add 200 on the X position, and that's going to be our end position. There we go. So now we have our 2 positions. It's going to be time to actually make the cube move. So add a timeline node, just add a timeline. We'll call this move timeline. Double click it, and you want to go to track and make a float track. And what you see, you get this kind of like a graph where the horizontal line is time and the vertical line is like the value. And this graph will define our animation. You'll see it in a bit. First, you want to make 2 points by right clicking and then just say add key to this one. There we go. And then now in the top, you will see time and value. And the first point is important, that's going to be 0, 0. And then we're going to add 0. There we go. We're going to add a second point, which is going to be at 1 second. And very importantly, the value also needs to be 1. So you have one value that's 0 and one value for 1. We're going to use that in our second step for this. You can use these buttons to actually see what's going on. So now we just have one line going from 0 to 1 over 1 second. I'm just going to right click on this and say break, and this will make it a nice S-curve instead of a linear curve. And that will make the animation a lot less robotic. So back in our event graph, we want to use the lerp node. This node will blend between our start location and end location based on this timeline's output value. So we're just going to get a lerp and a vector lerp because we have 2 vectors. We're going to get our begin position. So get begin position. Plug it in here. We're going to get our end position. Plug it in here. And then finally, you have the output. If you double click on the line, you can make a reroute node to make your code a little bit more readable and cleaner. There we go. And finally, we need to actually set the actor location. So on update, so this timeline, whenever it updates, it will call this set actor location. Again, the target needs to be self, and the new value will be this. So whenever this timeline is playing, let's also just move this in here. Whenever the timeline is playing, it will update the actor location to go from the begin position to the end location based on this graph's speed, basically. So it will take 1 second with this speed. By the way, if you are a beginner at blueprinting, there's a lot of useful nodes that we just used, and you might not know about it, like the timeline, the set actor location, or the get actor location. I made a video about the most used nodes where I gave a brief explanation of each node, so make sure to check that one out. So when I click play, you will briefly see the cube move. However, you can barely see it. So I want to change the offset that the cube moves. So what you can do, you can go back to the blueprint and change this value. But I want to make this a variable that I can change in the details panel within my level. So we can do this by first making this a variable by just right clicking on this pin or just drag whatever you want and press promote to variable. And we'll call this X offset. There we go. Now in the details panel, we want to make this instance editable. This means that the variable can now be changed within the level instead of only here in the blueprint editor. So compile save, and when we go back into the level, select the cube, you'll now see it is X offset. We can just edit this value to however we want. We put it to 5,000. It's probably going to clip through the wall, but that's fine. Oh, no, even. There we go. It's definitely moving. Very noticeable. So I want to increase the duration that it moves. So just grab this point and I'm going to set this to like 4 seconds. It should be value 1. There you go. And now when we press play and Okay, the cube moved. Okay, so I think what happened here is this value got set to like point something. It should be set to 1. So let's set this back to maybe like 500. Play it. There you go. It's moving very slowly. Maybe 1500. There you go. It's already moving a lot quicker. And it's clipping to the wall. So one final thing I'll make is to repeat this event every X seconds. And I can use a set timer by event node. This will fire off an event after X seconds, and I can choose to repeat this by selecting the looping checkbox right here. But first I will have to create a new custom event. So here add custom event, and I'll call this move cube. Custom events are also just basically like, yeah, you can see it. It's just an event. It's just one that I create myself. I can just call it wherever I want here. So move cube. There you go. Now you just call this event. So I'm going to remove this logic from begin play and just have the set timer by event being triggered by the begin play. And when this event is being triggered, that's when I want to set these values as well. So yeah, on begin play, we have this set timer by event node. I'm going to give it a time in like 5 seconds. So this is time in seconds. And I'm going to set it to looping. And then from here, you can do either two things. You can either drag the event to this like little delegate pin. It's called a delegate pin on the event. Or you can do this, you say create event, and then you just select the move cube custom event that we created earlier. Personally, I like this a bit better because it makes your blueprints a bit cleaner. After 5 seconds, our event will execute and it will repeat this because we put it on looping. Oh yeah, a little point, make sure you drag the execution line into the play from start. Timelines don't reset themselves, so just trying to play it wouldn't really work. Let's test it. You see nothing is gonna happen. We have to wait a little bit. And it's moving a bit. There we go. It's still moving a lot, so we cannot actually see it looping. So let's put this back to like 200. Play it. There you go. We're moving a slight bit. Get this out of the way. I cannot. There you go. It's moving again. You can also just stand on it for now. And it's moving again. We basically have a cube that just moves and stops. And it collides with our player, apparently. So to recap, we started with determining what we wanted to make. We wanted to move a cube from point A to point B. For this, we needed 2 points, a starting and an end location, and some way of making it move over time. We determined that the timeline and lerp node can make a value change over time with the velocity we give it. Using the 2 points we set, we made the cube move over time. Thinking about your logic in small chronological steps, like I just did, will become very important if you want to start making functionality for games. And that covers level 2. And as I said, this is the broadest topic of them all, and you can go a lot of different directions, making basically anything you want with blueprints. I would suggest getting familiar with the most used nodes and playing around with them by just making some basic features like I just did. In level 3, we will be taking a look at player input in Unreal Engine. As you might have noticed, if you created your project using the first or third person template, some basic player input is already set up. You can walk, look around, and jump right away. All of this is handled by Unreal's enhanced input system, and in this level we'll take a look at how it works and how to add your own key bindings. If you open the player character blueprint, which by default I think is here, third person, blueprints BP third person, there we go. You'll see there's a lot of nodes placed already, and all of these just handle player input, like walking, camera input, and jumping. And if you take a closer look at the begin play section, you see the node add a mapping context, which is set to IMC_default. IMC stands for input mapping context, and it's where we assign actions like moving or jumping to keys, mouse buttons, or controller inputs. So let's take a closer look how this actually works. So when we open IMC default, I'm just going to use this magnifying glass, and we'll just open the folder for me, IMC default. We open the mappings dropdown. You actually see the existing mappings, jump, move, and look. And each of these are bound to a button. So jump is bound to spacebar, a controller button, and even a button on your phone. So these are input actions, IA_jump, input action jump. And to create an input action, it's actually a separate asset we have to create. So let's create a new input for, let's say, interacting with the E button. It's a very common thing you do in games. You can just click this plus on mappings, and then you can either just go to this input action button to create a new input action asset, or go to content drawer, actions, right click, I think here on the input, and then input action. Let's call it IA_in interact. There we go. So the only key setting here is the value type you see here. Since we just want something to happen on a button press, leaving it here on digital is fine. So the other options here are like 1D or 2D axes for inputs like movement or camera rotation. You can now find IA interact in the dropdown. So open this dropdown and we want to assign this to E. So I'm just gonna open this keyboard button and press E. This has recorded my input and this mapping is now set to E on my keyboard. So additionally, you can also add more mappings if you want to have it on multiple buttons or, for example, on controller. You can just add one here and then, yeah, you can search for something like a gamepad and there's like a lot of things you can assign this button to, but let's not do that for now. So let's go back into our character blueprint. Let's go down a bit so we have some space to work with. Right click and I can now search for IA_interact and there you go. This is the event. Every time we press E, this one will trigger. So let's hook this up to a print string. Compile save, test it. And when we press E, there we go. It works, but it prints out whenever the key is held down. So let's go back to the player character and instead of triggered, I'm just gonna hook it up to started instead. And there you go. Every time I press E, it will create a new string. So to recap, the player input is handled through the enhanced input system. This uses an input mapping context where we map actions to keys or buttons. Input actions are used to define what kind of input you want to add. Just a button press or a 1D, 2D or 3D axis. Once mapped, we can then handle the logic in a blueprint by using the input action event. In the last level of this tutorial, we will be going over UI, the user interface. In Unreal, you make all of your UI in widgets. These are special blueprints made for creating UI elements. So in your content drawer, let's create a UI folder first to stay organized. It's called UI, open it. Now here on the user interface, we want to actually create a widget blueprint. We're gonna call this WBP for widget blueprint underscore. Let's just call it UI for now. Very bad name, but let's go with it. So as you can see, this layout is a bit different than the blueprints layout we've seen in level 2. In the top left, you will have your palette and your library. You can use one of these two to add elements into your UI. In the bottom left, you will have your hierarchy. And if you're familiar with software like Photoshop, this is your layers panel. You'll notice that when you try to drag in one of the palette elements, like let's just drag in a button, it will be incredibly big. And this is because there is no canvas panel. And a canvas panel is basically a paper you can draw on. Canvas panel, drag it in. And now we can just add a button, drag it in. And there you go. You can just place it wherever you want and it's not super massive anymore. So ideally you would use horizontal and vertical boxes like this one, horizontal or vertical box, to align your UI elements a bit better. But let's not do that for now. And I'm just gonna keep it free placed like this. So in the top right, you can see we are in the designer panel, but by clicking on graph, you can add functionality to your widgets. And there you go. We have these events again that we know from level 2. And here you would add custom events like decrease health, add score, etc. And these events are then called from another blueprint, like your player. So let's make a health bar go down when we press the interact key. That's the keybind we just set up. So back in the designer panel, I'm just gonna remove this button and I want to add in a progress bar. There we go. Gonna make it a little bigger like this. That's nice. And here under appearance, I want to make this a red color for health. And in the hierarchy panel here, I'm gonna call this health bar. There we go. And then here under anchors, I want to set this here to the bottom left. So it will stay in position when I make this a different resolution. There you go. It will kind of like stay in position. Now back in the graph panel, we make functionality for decreasing health. We start by making a custom event, just custom event. We call this decrease health, if I can see it, there you go. And we actually want to add an input value, which is gonna be health of type float. So this is a number value that's basically sent from wherever we call this event. Now we get the health bar variable, which is just the UI element that we just added. We get the percent, there you go, it's a float value as well. Now we want to subtract it by whatever is going to be coming from this value. So maybe instead of calling this health, maybe let's just call it damage. Because in theory, whatever is in this percentage is our health. So we're going to subtract that by whatever this damage value is going to be. Finally, just drag this value and say set percent. Or let's first call this health bar and set %. And drag this in here. And then there you go. That's our code. It's quite easy. But since we're using percentages here, we want to divide this damage value by 100. There we go, 100. And that then goes into this value. So whenever this event is called, we send a float value with it. And we're going to use that float value here to first make it a percentage by dividing it by 100. And then subtracting it from our current health. And then lastly, we're just setting the percentage again so it actually updates this health bar. So in our player character blueprint, we have to tell that we want to show this widget on the screen first. I'm going to do that on the begin play here. So I'm just gonna do create widget. And there you go. And then in the dropdown, we want to get this WBP_UI that we created earlier. We want to make this a reference, so promote variable, so we can use this later. That's important. I'm gonna call this a UI widget. And with that, we want to add to viewport. So what happens is on begin play, it will create this UI widget, make a reference of it, and it will make sure it's visible on our screen as well. So when we play, you can see the health widget is right there. However, it's gray, it's not red. And that's because we forgot to set a percentage here in the UI widget. So we just want to set it to 1. There you go. Compile, save. Now, when I press play, it will be red. Now, the last step is to call the decrease event. And this is actually very easy because we already have this input action. We're just going to delete this hello. And on started, we're going to say, we're going to get our UI widget actually. And just call decrease health. There you go. I misspelled the event. So let me just quickly fix that. Graph, just press F2, decrease health. So you can see here, we can actually input a float value that will be sent to this event. That's why we needed this input. Just set this to 5 for now, compile, save, test it. And when I press E, you can see my health bar is now going down. So this all works, and I'm sure a lot of developers will make their UI this way. But I think an even better approach is to call the widget reference from the player controller instead of the player character. The player character could possibly be destroyed depending on what your game is. Like for example, if you die, and the player controller will always stay alive in the world. So our approach will be to call to the player controller to fire off the event in the widget. So first we need to create a new player controller. I'm just going to third person, and I'm just going to do it here. So it's going to be another blueprint class. And there you go, player controller. And we call this player controller. So then I'm going to open the player controller in the event graph. On begin play, I'm going to do the same as we did in the player character blueprint. So create the widget, which is going to be the WBP UI. I'm going to make it a reference. So UI widget. And I'm going to add to viewport. And I'm just going to delete that from my player blueprint because we don't need to do it twice. So now this reference is stored in the player controller, and we just call the widget events that we created here from the player controller using this reference. So then I'm gonna create a custom event in this blueprint, which we can call from whenever we want. And I'm gonna call this from the player blueprint. I'm gonna call this decrease health. And just like how we did it earlier, I'm just gonna give it a input damage, and then it should be a float variable. There we go. So from the widget reference, we're just going to get the decrease health. And we're just going to hook this all up to each other. There we go. So in the player character, we want to call this event. We're going to do this here. Remove this from here because we're doing this in the player controller. On started, we're going to cast to the player controller. And there's actually 2 of them now. So let me actually just rename this one. Default player controller. And now cast to default player controller. There we go. And you want to get player controller. And then from the blue output, we can call decrease health, which will just call this event that we made earlier. And here we can just add the damage value, like 5, like we just did as well. And if you play, it's probably not going to work. There you go. You don't see the widget on your screen. Because you actually need to set the player controller, because right now it's using the default one that's being made by Unreal. So you do that by going up to window, and then you have ruled settings. And then in this drop down, selected game mode, player controller class, we want to set this to default player controller. Click play, and there you go. We have our widget. Press E, it will decrease health. Everything it just works as previously. So what we've done is we've put the call to the UI in the player controller instead of the player character. This is a class we can always get and it won't ever get destroyed. The only thing we need to give to the controller is the amount of health to decrease, so the damage. And this variable makes sense to save in the player character blueprint, and we just send that or transfer it to this default player controller in here. So to recap this level, we make UI using widget blueprints. In the widget blueprints, you can add UI elements on the canvas panel and change it to however you like within the details panel. You can also anchor UI elements so it stays in the same position when using a different resolution. In the graph view, we can add custom events that can be called from any blueprint. In this blueprint, you would create the widget, store a reference, and add it to the viewport to display it on screen. Using this reference, you can call to events you've created in this widget to update UI elements based on gameplay events. For the final step of this tutorial, we're going to combine all the levels to build a simple game. And if you've ever played Minecraft, you might know the minigame TNT Run. It's a great first project to start with. As discussed in level 2, you usually start with breaking down the mechanics. So in TNT Run, you have blocks that you can walk over. When standing on a block, it will fall down after a short time. There's multiple layers of blocks, and the lower you go, the faster the blocks will fall. And not to forget, there's also multiplayer, but for the scope of this tutorial, I'll skip that part and instead I'll replace it with a timer that shows your score when the game ends. Alright, so let's start with the most basic part, and that's making a block fall down when standing on it. Create a blueprint, an actor, we call this BP TNT. You open it, and first thing I'm gonna do is just adding a cube. So this is just a static mesh. You can also just the shortcut is just making a cube here, and it will just make a static mesh with the shape of the cube here. So then what we want to do is we want to detect when the player is standing on it. So we need some kind of trigger above this cube. We can easily do that by, again, adding a component, box collision. So now we have a box collision. If you move it up a bit, you can see it. Just make sure it's a bit spread over your cube. So there you go. That's going to be the detection point where the player is like, oh, okay, the player has stood on this block. So how this is going to work is by default, a static mesh does not have physics. So if I go into this level and drag up this cube, press play, you will see the cube will just fly, right? But when I go back to the details panel, and then in the mesh, I set simulate physics to on. So now we give it physics, you will see it will just drop down. So we just gave it gravity and can just move it around like that. And that's gonna be the system. That's how we're gonna make these cubes fall down. So initially they're just flying, and as soon as you stand on it, we're gonna give it a bit of a delay and it will then fall down using physics. As soon as the player stands on this cube, we want to do something, and we want to use this event here on component begin overlap. Click the plus and it will instantly create a new event for us. So when we overlap, we want to check, hey, is it the player that we're overlapping with? So we do that by casting to the player character. I think third person, cast to third person character. There we go. When that succeeds, we want to make a little delay, say 2 seconds. And then we want to get the cube and, like we just did, enable physics, enable gravity. Set enable gravity to true, sure. And just for ease, I'm gonna actually, for now, make sure that's gonna happen on begin play. So now on begin play, it should fall down. And it does not, that's interesting. All right, it should be simulate physics, set simulate physics to true. And now on begin play, it will just drop down. So we tested it. We don't really need this anymore. We're just gonna make a little level out of this. There you go. They're starting to fall, and it's actually quite difficult. So what we just did is we changed something in the details panel of this static mesh component. As you can see here, if I just, select the cube, it's just this cube that we added earlier. You have all these settings. For example, now we just altered the set simulate physics. You can see simulate physics, but I can also just do like linear damping or angular damping or enable gravity. There you go. You can just basically change all of these values if you just get the component and just search for it. And that's what we just did with the set simulate physics as well. So next up, we want to detect when the player is actually dying. Right now we can just walk and, well, we can fall down, but nothing is actually happening. For this, I want to make a huge trigger box at the bottom. I think you can also use a kill Z volume, but I'm just gonna make my own trigger box. So back in our content drawer, just let's go to blueprint class, make an actor. We call this BP underscore kill volume. And all we really need here is just one trigger box. And what you can actually do, I think, is let's just get this to the main panel again. When we drag this into the level, you can already see the box, and from here we can extend the box. Here, box extend. Here we can just play around with X, Y, and Z values. I don't need it to be very high. I think the Z axis is fine, but let's just extend it a lot on the X and the Y. Let's just copy paste. So we have a nice square, and this is gonna be our kill Z volume, or however you want to call it. Place it a bit more down, so it's beneath our blocks. So now we're gonna just do the same thing. We're gonna select the box trigger, scroll down until you find the on component begin overlap event. We click the plus, so it's added to our event graph. And then we're gonna check if it's the player that we're overlapping with, because we don't want something to happen if, for example, the TNT overlaps with our trigger box. So we do that by out of other actor, cast to your player. In our case, that's a third person character. And then for now, I just want to test it by printing string and say, you died. There we go. Compile and save. And then when we play, we stand on the thing. It falls down. You see in the top left, you died. Great. All right, so let's leave it at that. Right now, I kind of want to make this a bit more interesting. I want to connect the moving platforms. I want to make a moving platforms out of this. And luckily, we already made a little demo of that earlier on in this tutorial. So I'm just going to use the exact same system. On begin play, I wanted to have a timeline that just goes back and forth. We have a little X offset. And with that, we're just making moving platforms. One tiny change I want to make here is I want to have a Boolean that controls whether or not this TNT, so this is one TNT, if it should move or not. If the Boolean is true, it should move. If it's not true, it should not move. So I'm actually just going back to one of the blueprints I created earlier and literally just copy this into the BP TNT. Paste. There we go. And you'll find that we have some gray nodes. This means that these variables, they do not exist yet. You can easily do that by right-clicking on it and create variable begin position, create variable end position, create variable X offset, compile, see if we get any errors. The answer is no, so our code should be working. However, it made this X offset 0, so let's just give it the default value of 200 and make sure it's instance editable like we just did as well. So right now, if we have a TNT selected, you can see the X offset is now changeable from this panel. But as I just mentioned, I want to make a tiny change to this code. As opposed to earlier, I want to have a Boolean that controls whether or not this TNT should be able to move. So let's just make a Boolean can move. We're just going to create some space here by selecting everything here, dragging a bit to the right, because here we actually want to have a branch. So a branch is just an if statement. So if this is true, only then should it be able to fire this. If it's false, we're just not going to do anything. Also, just for sanity's sake, I'm going to make this into functions. So I'm going to right click on these and collapse to function. And I'm going to make this, I'm going to call this set positions. And then let's collapse all those nodes into a function. So you might think we should also convert these nodes into a function. And you could do it for these nodes, to be fair, but you cannot do it for the timeline because it's a latent node, meaning it takes time for this node to execute. And therefore, you cannot put it into a function. More about functions in one earlier video I made, by the way. So now our nodes, they look a lot cleaner, our blueprint. By the way, if you select this node or any node and you select another node, press Q, it will just instantly line it up. It looks a lot cleaner as well. Just beautiful straight lines. All right, so this is the code for a TNT currently. We have this set timer by event every 5 seconds. It's gonna move the cube. I'm thinking, do I even want that? I think I just want the cubes to move back and forth. So I think we don't even need the set timer by event because we can just open up the timeline. Instead of having this go from 0 to 1, I'm gonna make another point. If we zoom out a bit, add key, and we put this to time is 2, and the value is 0. Actually, our first point wasn't 4 seconds, so let's make the time 8 seconds in that case, and then value is 0. And just like that, we make it break as well. So there's a nice S-curve. Maybe this one as well in that case. Break, there we go. And I think if we click this button, it will just loop. So that's what I want to do. Oh yeah, by the way, we didn't do this before, but let's make can move instance editable as well. Compile and save. So now it has a beautiful can move button. and an X offset. So I want to test if this works. So we put only this one on can move, and well, it's not moving yet. Right, that's of course because we're not calling this event yet. So let's on begin play, just call the move cube event. Now let's play, and there you go. We can see the thing moving, but it's moving very slowly. And it's also moving into the other cube. So let's first of all make this, let's say, minus 500, and then go back into a timeline and make this time 1 second and this time 2 seconds. Compile, save, and see if it works now. Well, it's definitely working, but it's not looping yet. And also I noticed the force is way too strong now, so let's put it back to like minus 200. And this is also part of designing a game, just messing around with a lot of these kind of values to make a game feel right. But this one is not looping yet. Right, so I think it wasn't looping because the length is still 5 seconds. You can change that here, change it back to 2 seconds, compile, save, play again. There you go. Now it's looping. We have a moving cube. So actually I want to make this code a bit more versatile, so we can also move it on the Y position instead of just the X position. So I'm just gonna make it the exact same setup as I just did here. I'm just gonna make an add. The code is a bit messy. You can remove lines, by the way, with Alt and click. Then we want to make a new variable called Y offset, which is going to be a float. And we can just drag it into here and want to make this variable instance editable. And then we're just going to plug that into the Y like that. And you could technically do the same for the Z, but I don't want to have moving platforms that go up and down, only sideways and front or backwards. So this is all for now. Compile, save. And now we can actually set the X in the Y position. So for now, I'm just going to make the Y above here. So now they should be under each other. There we go, minus 200 and 0. So in theory, I should also be able to just give it a minus 200 value on the Y offset. And now it should move diagonally. Very nice. So right now I'm just gonna make a simple level with a bit more cubes, a bit more interesting moving platforms as well. So I'll be right back. All right, so I've quickly expanded a bit on the level. So right now if I play, there's a lot of moving objects and I've made it myself a lot more difficult to complete the game, as you can see. All right, so the next thing is, well, usually it would be making it actually work with multiplayer. But for now, I'm just gonna make a simple timer that whenever I'm alive, it will show a timer on screen. So for that, I want to go to my widget that I made earlier in my UI, WBP_UI. And what I want to do is have a big text here that shows a timer. And that timer will be changed every second in this graph. I'm going to make a custom event for it. It's going to be called every second. And every second, it will just update this value. So that's dragging a text block. Default is just 0. I want to make it centered. Under here, justification 0, and I want to make this quite a lot bigger. You can do that under fonts, and then here, size, there you go. Maybe not that big. All right, so next up is in my graph, I'm gonna make a custom event, which will be update timer. So I don't see the text as a variable here, so what I can do actually is here on the text, make sure the is variable checkbox is selected. Oh yeah, also make sure to anchor it here. Let's anchor it to the top. So now in our graph, we can actually see our text block, and I'm gonna rename it to timer text. Now I want to store the time somewhere else actually, wherever we do the whole timer code. And here I just want to set that time to the text. So I want to add a input, which is going to be the time in, let's say, integers. Time, then there you go, integer, and we want to set this text, set text to this integer. That's all we want to do here. I could update this time in a lot of different places. I wouldn't suggest doing it in the UI here, but you can use like the game mode, or I think I'm going to use a player controller for it. So we did make a player controller before. I think it's under third person default player controller. So on begin play, we want to set a timer. So set timer by event. That's running every second. It's looping. And we do want to make this a reference. So we can at all times stop this timer. Because the good thing with making this a reference is you can just drag this in and you can call clear and invalidate timer by handle. If you call this timer will just stop at that point. So you want to create an event, make sure to make a custom event for this, and that's increase time. And now this is going to be very simple. We're just going to make a variable called time. It's also going to be an integer. By default, it's going to be 0. It's going to complain here that we need to assign a function. So increase time. There you go. So what we want to do here is very simple. So we just want to get the time and add 1 to it. You can either use the add like we've done before, or you can just do ++ increment int, and this will just add 1 to it. After which we want to send this value to the WBP UI, and we did make a reference for that earlier. So let's get it. And we want to call the function increase timer or set timer. What was it? Update timer. There we go. Update timer to ask me for an integer, which will be this value. So I think that should be it. So if I play, I have a timer on my screen that will just add 1 second on the clock every second. Very nice. All right, now the last thing I want to do is I want to make a game over screen that will just show the time that I've been alive. So to do that, I want to make a new UI widget. So here, right click, user interface, widget blueprint, and we are going to call this WBP_game over. So again, we want to start with creating a canvas panel. This is our paper that we can draw on, as you can remember. We want to have a text, and then for the important part, we want to add another text in here with our seconds. We want to make that a bit bigger. We want to center it as well. There we go. So now we need to somehow get the text from our player controller, this timer, and send that to this UI. So what we can do here is make sure this is set to is variable. We want to rename these to timer, this one to game over text. There we go. And here we don't need any of these. Well, we actually might need event construct. So this will just run every time this widget is being created. So then we're gonna get this timer text box. We're gonna set text, and then we want to get our player controller and get timer, if that works. Right, no, we want to cast to it, to our default player controller. So cast to default player controller. So again, with this, we just check, hey, is this the controller, the player controller that we're currently using? If yes, we can do stuff with it using this blue output pin. As you can remember, we had a reference, or a variable rather, called time. So we just want to get time, and we plugged it in here. So what we're doing here is, as soon as we construct this UI widget, so when the game over screen is displayed to the player, we cast to the default player controller because we want to get the time from the default player controller. And then we just set the huge tag box here to the time that's coming from the default player controller. Now, as you can remember, we made a die event for the player. I think we did that on this BP kill volume. So right now, I just want to replace the sprint string with a create widget, which is going to be the game over. And we want to add this to the viewport. So when I play, you will find out there is quite a big issue, and that's, well, I can die. The screen will show up. It will show me the seconds that I had whenever I died. That's good, but the timer will still update. I also want to add a background to this widget, but let's leave that for later. Let's for now disable this timer, or let's just hide it completely. And again, we've stored a reference here, the UI widget, which displayed our time. And this is a reference that we can call from where we have our dying logic. So whenever this happens, we also want to get our player controller, cast to the third person character, or the player controller, default player controller, there we go. Get our UI reference or UI widget and say remove from parent. Yeah, this will just delete the UI widget so it's no longer on screen. If we now play it, fall down. Oh, I got stuck. There we go. It will not show the UI widget anymore. Over everything, I just want to make it a bit like white-ish and just decrease the opacity like that. And then just drag this over the entire screen. Maybe make it a bit darker as well. So now when I play and I die, I get this screen. You died. So there you go. We've remade TNT Run from Minecraft. We have moving platforms. You can die. It will show your time on screen. And of course you can customize and make this game a lot more prettier to however you want, but I'm gonna leave it like this for a beginner tutorial. So we've combined all the levels into making a working game, and if you're new to Unreal, some of the concepts discussed might have been a bit overwhelming, but I've got a variety of tutorials that cover most of what we've done here today on a deeper level. If you found this video helpful or interesting, feel free to like, comment or subscribe. It really helps the YouTube algorithm to make sure other people will find this video too. On your screen right now is the video where I talk about the most used nodes, and it's a great starting point for people that want to learn game dev in Unreal Engine. Thanks for watching, and I hope to see you in the next one.